gases coming in impulses, like stop, stop. That's why sometime here 0, sometime 1.
Why is the
That I am coming to that point. Yes, sir. So this is pulsatile flow. Why pulsatile flow? Pulsatile flow has two advantages. One advantage is it gives time to our body to acclimatize with the increased pressure. When diaphragm moves up, it will push some gas. When diaphragm goes down, it will stop. It will try to synchronize with the diaphragmatic movement. This is first advantage of the pulsatile pressure. Second advantage of the pulsatile pressure is that it will sense the real intra-abdominal pressure when it is off. There is one problem with the varus needle. What is this problem? That when it pushes the gas, due to resistance of the eye of the varus needle, there is always one error. So the actual pressure is minimum of the 5 readings. And actual pressure can only be sensed when insufflator is off, when it is not pushing the gas. That's why you can see here it is sometime 13, sometime 4, sometime 15 and sometime 0. That means actual pressure is 0. Isn't it? It senses the real abdominal pressure when it is off. When it is off. When it is on, when it is pushing the gas, at that time it will sense the resistance of the flow, and that's why it is giving the error. Sometime you can see it is 0, sometime 17, again 0, again 13, again 0. That means minimum is 0. So the actual pressure is right now 0. Why it is 0? Because gas is going into the atmospheric pressure. It is not building up anywhere. So this is the property of the insufflator, that is initially with the varus needle it gives pulsatile flow. It will increase. If you will block, then it will increase. So it will be initially pulsatile flow, and later if you will detach the insufflator, automatically it will become continuous flow. Because, pardon? It is resistance of the flow due to the small eye of the varus needle. Because the gas has to flow under resistance. Again, if you will attach with the cannula, then error will automatically it will stop. It will start giving you continuous flow. So this is with the every insufflator. Once you attach it with the varus needle, it gives you error. Now we will attach it with, suppose it is attached with one abdominal wall. Now this way it is attached with this abdominal wall. And right now it is inflating, and we can see right now the pressure, minimum pressure is 0, because it is not distended yet. Still it is completely lax. But once the sufficient pressure will start building, then 0 will not come. So we can see here right now it is the minimum pressure is 0. So how you will know the actual pressure with the varus needle? Actual pressure with the varus needle will be known by the minimum out of 5 reading. Now you will see that minimum 0 will not come. How much is the minimum? Minimum is 4. Now the minimum is 6. That means actual pressure is 6. And as soon as this 12 will come, flow will itself stop. You got it? But there is some error, sometime 17, sometime 11. Why it is? Because due to the resistance of the flow, it happens. Now if I will, as soon as I will remove it from the cannula, this resistance of the flow is off, and now automatically it will become the continuous flow. Now it is continuous. If you will hear, it is continuous flow. Continuous. And this is continuous. There is no error now.
How much? You want?
Pardon?
One?
This is 1 liter per minute.
Continuously one.
Continuously one.
Yeah.
And if you will attach, let us take and attach it with the abdominal cavity, then the flow increase also will be 1. And this is slowly 1, 4, 5, 7, no error, no fluctuation, 10, 12. And as soon as this 12 will come, the flow is stopped. The flow rate is 0. Actual pressure is 12 and it is stopped automatically. So our main purpose of the insufflator is to keep the actual pressure at the level of preset pressure. If the pressure, if I will leak somewhere, it will again start flow and it is again coming to 12. Not only that, if I will press it from somewhere, like I am pressing it this way, then you will see it will withdraw the gas back. It is giving alarm, and after alarm it will take the gas back. Now it is taking the gas back. And if insufflator will give you 5-second time to correct your problem, 5-second time it will give you, it will give alarm. Why it gives alarm? Why not immediately it is withdrawing the gas? It is giving the alarm that purposefully if you are doing something, then finish your task. What happens? Suppose you have put your primary trocar and then you are putting your secondary trocar, then there is some pressure there because of the pressure which you are exerting, and at that time actual pressure will rise. So the insufflator will wait for 5 seconds, it will give you alarm. But within 5 seconds, if you could not introduce your trocar and cannula, then it will take the gas back. So remember that if within 5 seconds, if you could not introduce it, stop and then again press. If you keep on continuously pressing, then there is a danger of injury of the bowel or viscera, because abdomen will collapse, because insufflator will take the gas back. So while you are, suppose this is the trocar and cannula and you are pressing like that, any other gloves? So this way, if you are putting, you have to take care that the pressure should not be there, otherwise abdomen can burst. This way.
That's the flow rate the same, or the velocity and the
No, flow rate is different. I am coming to this point. So now this is this way, it is there and it can withdraw it. Now, but what you have seen here, if there is leak and if you have set to 1 liter per minute, it will take a lot of time to abdomen to get inflated, and by the time you can have 1 cup of tea also, because it is taking a lot of time, because normal time taking for various-needle insufflation is approximately 5 minutes. 5 minutes is sufficient time. If it is collapsed, again you wait for 5 minutes, isn't it? So when your cannula is in, you should put your insufflator to 0 to max. When your cannula is inside, you should put your insufflator to 0 to max. What does 0 to max mean? 0 to max means that if it is required, flow rate will be maximum, and if it is not required, flow rate will be 0. And automatically insufflator will decide. You don't have to worry about, like I will show you here. Right now the flow rate is 0, but now I am leaking. I am leaking now, and it is flow rate is 1 liter per minute. Now I am leaking further. Flow rate is 5 liter. Now it is flow rate is 8 liter. Now flow rate is 10 liter, and still that distension of the abdomen is maintained. Can you see? And it's a big leak. I have almost stopped it, and it's a big leak, and it is compensating. But if I will stop it, it will gradually go down and it will come to the 0. So if your insufflator is 40 liter, it can replace the leak up to 40 liter per minute, isn't it? If it is 9 liter, then maximum it will replace the 9 liter per minute. And when your cannula is in, you should keep it to the maximum flow rate, like 40, or if you have the bar like to increase. Here it is 0 to max. 0 to max means if it is required, it can go up to the maximum, and if it is not required, it will be 0 also. Automatically insufflator will decide that what should be the flow rate. It depends, all companies, it depends upon the amount of leak. If there is no leak, flow rate will be 0, and if there is any external pressure like that, it will wait for 5 seconds, and after 5 seconds this alarm starts, and then it will take it back. Now it is taking back.
Do you usually do your surgery surgeries with that mode on?
Yes, generally always the laparoscopic surgery should be done with the 0 to max, because surgery you cannot do at 0 to 1. 0 to 1 is very simple. Why? Because our flow rate should never be more than 1 liter per minute. Otherwise, if the gas is going into the vessel, there may be chance of air embolism. But when you are performing surgery, you should have the maximum, because if bleeding has started, if you are sucking, or if there is any gas leak, in those situations you don't have to worry, insufflator will take care. It will replace the amount of gas which is lost. So this is known as flow rate. There are two types of flow rate. One is 0 to 1, another is 0 to max.
Having 40 liters of leaks
Maximum
data,
capacity.
doesn't it affect the
No, there is question. No, question is that if there is a leak of 40 liter per minute, does it affects the surgical team? The answer is no. Why? I will tell you that carbon dioxide is not a poisonous gas. Carbon dioxide has only disadvantage that it doesn't support life. It never kills life. You will be surprised that every minute we ourselves are taking out 100 to 200, it depends upon the metabolism of the person, carbon dioxide outside. And carbon dioxide is good for the body because it increases your hemoglobin. Only problem is not the carbon dioxide. Problem is that if there is a lot of leak and if the interior milieu is breached, then a lot of carcinogen, viral DNA and bacteria are present inside the closed compact compartment of the abdominal cavity. And if you are inhaling those particles like smoke, like the vapors after harmonic, and there is fragments of the DNA, viruses, bacteria, pus cell, and sometime when you are opening that like this and it is gushing, it will the gush of the fluid in your nose, or it can create sometime infection to the surgeon. This is only concern. Leak of the CO2 is not a big concern to our health, because the amount of that much CO2 doesn't create any known problem. So it is very safe. But unnecessarily leak should not be there. Why leak should not be there? Because if you are leaking a lot, you have two drawbacks. One drawback is that if you leak, then first is your patient will get hypothermia. If you are leaking more than 5 liter of the CO2 for more than 5 to 10 minutes, then your patient will start having the hypothermia. Why hypothermia happens? Because the rapid flow of the gas touching that bowel peritoneal fluid and again leaking creates evaporation, isn't it? And that evaporation will exhibit cooling, and due to that patient will start having, if patient is under local anesthesia, then she will start having shivering. But if he is in the general anesthesia, there will be no shivering, patient have the myocardial depression, and then there will be the ventricular arrhythmia, and after that there may be ventricular fibrillation. So you should must concern about excessive leak. If excessive leak is there, this is the one consequence. To stop that, many companies they start using the CO2 warmer. Insufflator is having inbuilt CO2 warmer. The good thing that it will keep the CO2 warm, so that hypothermia will not develop. But CO2 warmer is even more dangerous, because what it creates, that if you have a CO2 warmer and you are relaxed that I can leak now, I don't have much to bother because my patient cannot go to the hypothermia, then your patient will start getting adhesions. And what happens? Why adhesion? Because rapid flow of that warm CO2 creates the evaporation mode, and there will be dryness of the serosal surface of the bowel. And after that, this serosal injury, superficial, can create the fibrosis and then adhesion. Just like when you do laparotomy, and when you are taking the coil of intestine outside, you are very much worried about that it should not dry. You are taking a sponge wet with the saline and you keep it there repeatedly, so that keep it moist. If it is not there, it will become dry, and you are tensionized that why it is like that. But using CO2 warmer means you are keeping it outside and you are drying it by hair dryer. Means it is warm air you are pushing over that. In laparoscopy we cannot see at that time, but it gives such a bad adhesion, sometimes very long duration paralytic ileus, and sometimes others rarely fistulization and obstruction also can happen. So leak is not good. Wherever you are leaking somewhere, you should immediately try to stop that leaking. Nowadays the companies, they have started the CO2 warmer with humidifier, and if you will buy that one, then it may be good, because CO2 warmer with humidifier if you will use, then humidity it will maintain, and then evaporation will be less, dryness of the bowel surface will be less, there will be less chances of adhesion. So even if you have a 40-liter insufflator, it is not wise to leak, and you should keep the insufflator setting at 4 or 5, so that if there is more than 4 or 5 millimeter of mercury leak, then you will appreciate immediately, because your abdomen will start collapsing, and then you can correct it. How to correct? What are the places where leak can happen? First place is your wound itself. If your wound is big, then it may leak from the wound side, port side, and then you may need 1 or 2 stitches just to close it. Another way of leaking is that at the level of your valve, like sometime the inside the valve, this is the valve and there is the washer inside. If you will see, there is one yellow washer inside, yellow one, and this is the yellow inside, and this is just like the washer of the pressure cooker. It has a washer here, this yellow one, and if it will get torn, then this will leak. If it is instrument is inside, then it will not leak, but once you have taken the instrument out, it will start leaking from this valve. So this is the second point where leaking can happen. Third place is this rubber itself, and if it is torn, like I will just show you that sometime with the repeated use it get torn. I am just tearing it. Now it is torn. Can you see?
Yeah.
It is torn. It should must be replaced. Just like it is not visible, but if you will go there, now it will leak from here, isn't it? And even the reducer is there, even the good quality instruments are there, just due to this 10 rupees washer, it is leaking all the way. Every time it will keep on leaking. And if you don't have this one, now you are in trouble. You should immediately replace it. Now my question is, what you will do if you don't have this one? If you don't have this one, then you can, and you have to do surgery. And if it is leaking, pardon? Wet gauze piece will not solve the problem. No. What scissor hai? What you do? Take one scissor and cut the finger of the gloves at 2 places. I will show you how to solve the problem. That you cut the gloves here, like this. Cut the gloves finger, right? And again you fold it and cut the gloves finger at this point, very small, like this. And your valve is ready. Now what you do? You put it here, like this, and then just in the center, nicely it will fix, and then fix this torn valve here. Can you see? And then put this torn valve over this. Now it will not leak, because it is making an artificial diaphragm here. And even if you will put your instrument, at least that surgery you can continue. It will not leak. And now later you can change it. So this way.
When we give suction irrigation, we are sucking out the gas also. So isn't that kind of a leak or leak?
Yes, suction irrigation is a kind of leak, but suction irrigation we use only if there is bleeding, isn't it? And at that time it is necessary. But if you are keep on irrigating and sucking, then there will no much dryness.
Even when we're doing the bipolar, we do that to release the gas. We should
No, it is not necessary. I don't know why many gynecologists what they do, that then when they burn the fallopian tube, immediately they irrigate it.
But he said it is a pretty
Yes, why? Because they make it cool, so that it will not harm the other tissue, but it is not required. Generally, I have not seen much in any of the big hospital, but I have heard that some people they do that. It is not required at all. It might be why this habit came, that before long ago we were using the thermal cautery, and in thermal cautery there was the heat which was destroying the tissue. But these are the high frequency radio frequency wave current, and they don't produce much heat. The changes in the tissue is due to the turbulence of ion inside the cell, vibration of the ions inside the cell, and mechanism is completely different. So heat produced is very less in this type of cautery machine. I will discuss regarding the cautery later. So it is not necessary to irrigate it. So this way, these are the few points which we have to keep in mind. Now comes to the total amount of gas used. Total amount of gas used for a normal built abdominal cavity to get a preset pressure of 12 is minimum 1.5 liter and maximum 6 liter. Total amount of gas used for a normal built abdominal cavity to achieve preset pressure of 12 is minimum 1.5 liter and maximum 6 liter. What does it mean? That if I have to create a pneumoperitoneum which should produce a preset pressure of 12, actual pressure of 12, then I need minimum 1.5 liter gas in my abdomen, and maximum is 6 liter. Now what are the variables? Why in some patient I need only 1.5 liter and why in another group of patient I need 6 liter? What are the variables? The first variable is the size of the patient itself. If you have a small patient, then you need less gas. If you have a very big, tall, 6.5 feet patient, then you need maybe 6 liter of gas because size is big. Another variable is amount of muscle relaxant. If your patient has a good amount of muscle relaxant, then after 3-4 liter of the gas, then you will get actual pressure 12. But if your patient is tight, muscle relaxant is not sufficient, then within 1.5 liter itself, you will get the actual pressure 12. You cannot accommodate much gas because abdomen is tight, it cannot inflate. Third variable is bowel preparation. If your patient has received the peg-leg powder is better to give, especially in the gynae practices. Peg-leg is polyethylene glycol. Peg-leg is the polyethylene glycol. Name itself P means poly, E means ethylene, GLAC means glycol. So polyethylene glycol peg-leg powder should be given 1 sachet or 2 sachet prior to the night of the surgery, especially for the colorectal surgery, for the hernia surgery, for the LAVH, salpingoophractomy, or almost all the gynae procedure. It is good habit to have the bowel preparation. If you have a good bowel preparation, your patient can accommodate more gas. But if she had a nice lunch dinner last night and you didn't care for the bowel preparation, and she will come, she has a full intestine, and within 1.5 liter of the gas you will get that much pressure, 12. Another variable is any space occupying lesion, like if your patient has the big fibroid or big uterus after pregnant woman, or there is a big ovarian or dermoid cyst, then you cannot expect to have the much gas inside. Just within 1.5 liter you will get the 12 millimeter of mercury pressure. So these are the few variables which you must keep in mind. And most important is the size of the patient and muscle relaxant, that varies immediately. But no matter how much big the patient is, she will never accommodate more than 6 liter. And the adult patient, no matter how much a small size, even 4 feet height of the patient, 1.5 minimum is required. This is the total amount of gas used to achieve a preset pressure of 12. Now if the preset pressure is suppose 18, then this will shift. If you want to get 18, then the minimum amount will be approximately 2 to 3 liter and maximum will go up to 8 liter. Because if you want to increase the preset pressure, then more gas can compress there, isn't it? And total amount of gas used will be more. This was just to achieve your pneumoperitoneum before putting trocar. Now how much gas is used after introduction of trocar? Suppose your surgery is continued for 1 hour, then no matter how much good you are, how much good your instruments are, average 18 liter of the gas will be used. 18, 1/8 liter of gas will be lost. In that 18 liter, 20% of the gas, that is 3.6% of the gas, 3.6 liter of the gas is absorbed by our body. It is absorbed by our body, but it doesn't have any harm because it is absorbed and then expelled by our respiratory system. So we don't have any bad effect out of that. In 1 hour, we expel 3.6 liter of the minimum at 12. But if you will increase the pressure to 18 and all, then it will be 4 times more than this one, because the rate of absorption increase 4 times more. So the total amount of gas used in 1 hour is approximately 18 liter in the normal circumstances. Now in abnormal circumstances, it may be 100 liter. Like all the washers are wrong, they are leaking, your port size is not good, your instruments are 10-year-old, everywhere it's a leak, and your insufflator is pumping anyhow the gas. Within 1 hour, you have used 100 liter. And maybe it's very bad for the patient, because patient has the more risk of dryness of the bowel, more risk of adhesion, more risk of having hypothermia as well. So this way insufflator has to be keep in mind. These are the 4 settings. Now if you will see here that when your insufflator is off, right now there is air inside. Right now there is air inside. And this air is very dangerous, because if you will connect the varus needle and then connect the tubing and then switch on the insufflator, first this air will go into the vein, isn't it? Suppose overnight I have not used this insufflator, this tubing was sterilized, this insufflator was sterilized. Now amount of air starting from this tip up to the cylinder is 800 ml, and that 800 ml air is sufficient to kill your patient if it is inadvertently going into the vein, because it will create immediately air embolism. That's why in the insufflator there is one safety feature. What is that safety feature? That if you will attach the insufflator and with the varus needle, and then if you will switch on the insufflator, it will give you the error message. If you see here, it will give you error, and this is the error. Why error? Because and it will block all the switches are blocked. It will not work. It will not work. It is blocked, and it is giving you error. Why it is error? Because you have not evacuated the air which was present into that, and this is a safety feature. So now what you have to do? Disconnect the insufflator, switch it off again, and then again switch it off. And now if you will feel, it is expelling the air. Can you see? Air is expelled, and this will expel 800 air out, and then it will come to the standby position.
That was with the varus needle in the abdomen.
In the abdomen, it will not put the air inside. Even if this feature is not there in your insufflator, you must take care that never attach the insufflator first and then switch on the insufflator. Insufflator should be switch on first and then connect with the varus needle. Just like IV drip, when you are putting, your nurse should take all the air from the IV channel out. So that air, once it is out and once at the tip there is only saline, then it should be connected. Exactly same way we have the air inside, and without flushing that air out, if you will directly connect it and then switch it on, then air will go and that air is dangerous. So we should take care, and in insufflator also this precaution is given so that machine will take care itself. So this was the 4 setting, that is the preset pressure, the actual pressure, the flow rate and total amount of gas used.
What is the capacity of the cylinder?
Cylinder has a different capacity. The minimum capacity, cylinder comes with the capacity of kg, that is kilogram in kg. There are 2 kg cylinder up to 7 kg, 8 kg, 20 kg. Like here, this one is 20 kg cylinder. And 1 kg has 22 liter in 22 Pascal pressure. So average one surgery needs 18 liter. So with 2 kg cylinder you can perform 2 or 3 surgery. If you have a 20 kg cylinder, then you can perform 5-6 surgeries also. It depends how careful you are to use this carbon dioxide. Suppose you are leaking a lot, then maybe 1 cylinder will be finished in 1 surgery also. It depends upon all your habit, your experience and your quality of the instrument what you are using.
How much is the capacity
How much capacity is
of this insuflator and how do you know how much capacity?
there, you can immediately know. You disconnect it and switch it on with maximum flow rate. You will see that this flow rate is going. This is 18 liter insufflator. This insufflator is only 18 liter capacity. So if you have the bigger one, 30 liter, then it will show you 30 liter also. So actual pressure will be seen. Now, yes.
Those separator, there's a filter for that.
Yes, the filter CO2 here also you can attach. Outside there CO2 filter. What is that? Sometime there may be some impurities in the CO2. Impurities in the cylinders. So it will filter like some dust particles, some fibers. If it is there, it will filter. So in some insufflator filter is inside, in some insufflator filter is outside. If you will remember a storage insufflator, in the storage insufflator there are only 3 columns. There is no 4th one. But 4th is always there, it is hidden. When you will press the first one, press it, then it will show you actual preset pressure. And when you remove your hand, then it will start showing you the actual pressure. When you will keep on pressing, because if it is once set at 12, that means it will always remain at 12. So it doesn't need to show always. So when you will keep on pressing it, then at that time it will show you that preset pressure is increasing or decreasing. And when you remove your hand from this setting, it will show you actual pressure. So actual pressure and preset pressure both are given in same indicator.
How do you change the preset pressure?
Just you plus minus, just you go the minus, this bar, the column will come down. And if you will keep the plus, then this column will go up. And when you remove the hand, it will come to 0. That is actual. Or if it is inside the abdomen, then it will show you the actual. So it is hidden. But this quadromanometric indicator, it is known as quadromanometric indicator. Quadro means 4 and manometric means pressure. Quadromanometric indicator is recommended and it is must having indicator for all the medical grade insufflator. It is necessary.
The preset pressure is same for hysteroscopy also?
No, preset pressure of the hysteroscopy is 150 to 180 millimeter of mercury. That is with the fluid. That I will discuss later separately.
Regarding CO2, there are so many types of CO2.
CO2 has very many problems.